Today we're learning about ways you can communicate with your database, and one of the primary ways you can communicate with relational databases are SQL queries. Today we're learning everything about a SELECT SQL query. So as you can see here, we have a table called cars. We have a lot of cars here. We have IDs, car makes, car models, year, perhaps VIN codes, and we could have perhaps other information. So what do we do if we want to select something from that table? How do we tell our database that we want to select a specific row from this table? How do we say that we want to see exactly this, only see this? Well, it's pretty easy, and in the database world everything's pretty similar to the English language too. So what do we say to the database is something like this: select everything from cars, and then we end the query and execute it. We can see that our query has failed because the database said that the column everything is unknown. So we specified that we want to select everything from the cars table, and the database did not understand that because it said that there is no column called everything in the table. And that's correct because we only have ID, car make, car model, year, and the VIN columns. So to select everything from the table, we use an asterisk instead, because this is how our database understands everything. So if we execute that query again, we can see that now we actually have everything that exists in this table. So with this select query, we see everything that our cars table has to offer. To actually filter data, we have to use the where clause. So we tell our database, select everything from the cars table where, and then we specify what we want to see. So we specify first the column and then the value in that column. So if we say where ID is equals 15, we tell our database that we want to see everything, select everything from the cars table where the column ID is 15. So when we check logically here, we see that the ID 15 is of car make BMW and of the car model 6 series from the year 2004, having this VIN number, right? So logically, our database should return only this record. And this is actually what happens. Our database only returns one record because we specifically asked it to return everything from the cars table associated with this specific ID. Now that we have everything associated with a specific ID in our table, we can also specify other columns to search for other things. So if we say that we select everything from the cars table where the car make is BMW, our database should return every row that has the car make of BMW in it, right? So let's check. But our database does not understand the query as well as we do, right? Our database says unknown column BMW in where clause. So in other words, our database does not understand what we are selecting here, what we want to search for. We tell our database that we want to select everything, asterisk, from the cars table where the car make column, we have a car make column right here, is equal to BMW. But the problem is that BMW is a string, not a column, right? So we define columns here, 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 and the problem is that this BMW is also specified as a column. Our database does not understand what we're searching for because it doesn't understand whether this is a string or a column. So what we do to fix this is we wrap this like so, specifying that this is what we search for. So if we wrap the value in single quotes or double quotes, we tell our database this is what we search for inside of those quotes, no matter what it would be. So let's run this again. Right, so now we see that we have everything from the cars table where the car make is BMW. We can see that the car make we see is only BMW, so our query did work. If we want to select columns, other columns from the same table, we just specify them as part of this here. We delete the asterisk, then we specify car model year from course where car make BMW. So this will return only those two columns, so the car make and the car model, and ignore the ID, the year and the VIN, because this is not what we ask our database to do. We ask our database to return the car model and the year. We don't ask our database to return everything where the car make is BMW. So let's execute this, and we see that we now see only the car model and the year. If we would include another column in that same table, we can check it here. If we would include the ID, for example, we would also see the ID in the result list. Also, always be aware of the fact that database management systems are likely to have reserved keywords. If you use those reserved keywords in column names, you are likely to get an error. So this is why in documentation and in other places you are likely to see queries written like this: columns wrapped in backticks. Backticks allow us to escape such errors, and they're not at all necessary, but recommended. Use backticks to escape errors. Now, besides escaping, we may also want to find something that matches two specific criteria or more. So we do that by saying select something from cars where the column, the car make, may be BMW, and where the year is, let's say 2004. Let's wrap this in backticks to avoid errors. And what we're saying now to our database is find me everything from the cars table where the car make is BMW. So basically find all cars of BMW car make that are made in the year 2004. So SQL is very similar to the English language because it supports both AND and OR operators and some more. So what we're saying is select everything from cars where the car make is BMW and the year is 2004. And now we see that we have multiple results where the car make is BMW and the year is 2004. We can also add that we want a specific car model. So if we say and car model equals to 6 series, we will be also able to filter the data even further by saying that we want cars of BMW make that are made in 2004 and that have the 6 series car model. Besides the AND keyword, we also have the OR keyword, and it works very similarly. If we say that select all from cars where the car make is BMW, we get everything related to BMWs. But if we say that we want to select everything from the cars where the car make is BMW or Ford, we may also say this: select all from cars where the car make is BMW or the car make is Ford. Let's see what's returned now. So we see that we see Ford and BMW. So our database understood that we want everything related to BMWs or everything related to Ford. In the real world, we may also want to return rows that fall within specific parameters. So let's say we want BMW cars that are made within 2000 and 2007, between 2000 and 2007. So we tell our database that it needs to select everything from the cars table where the car make is BMW, but that's not enough, because in this case our database will only return BMW car make cars. So we also say that and the year it's made in, and we say then between 2000 and 2007. So our database understands this query as I need to return everything from the cars table where the car make is BMW and its year falls between 2000 and 2007, which is pretty simple, which is what it returns. We see that we have BMW cars made in 2004, 2005, 2000, so basically everything that falls between 2000 and 2007. At the same time, however, this is not the only way this query can be written. We can also write this query like select all from cars, where the car make is BMW and the year it's made in is more than or equal to 2000 and the year is not bigger than 2007. So here what we say is select everything from cars where the car make is BMW and the year is higher or equal to 2000 and the year is no bigger than 2007, which is pretty much the same as the first query that we ran. And we can also say that the result set is the same here. We see that we have cars made in 2004, 2005, 2000, 2002, and 2007. So this is how the between clause works. You can write it either using between, either like this. Either way, the result set is always the same. It's the same thing. Very frequently, select is also used in conjunction with order by, limit, or offset. So if we tell our database that we want to select everything from the cars table and order data by the ID column in a descending fashion, we see that we now have a different result set. Our result set will be ordered by the ID column and it will start from the highest number because we specified a descending fashion. By default, data is ordered in an ascending manner. So if we say that we want an ascending manner, we see that the data comes from 1 to 6000. Order by also works with limit, or you can use it as is. So if we say limit 5, we tell our database that we want everything from the cars table and we only want the first 5 rows. This can be useful if you're building pagination applications or something similar. So you see that we have 1, 2, 3, 4, 5 rows. We can also say something different, something like select car make from cars, order by ID, limit 5 and offset 2. So in this case, we select two columns. We select the ID column and the car make from the cars table, order the data by ID in an ascending fashion by default because we don't specify anything here, limit ourselves to the first 5 rows, then skip 2 rows. Offset is skipping. So if we run this, we can see that we start from the 3rd row because we offset skip 2 rows, limit ourselves to the 5 rows, 3, 4, 5, 6, 7. So these are 5 rows, order by ID. So this is ordered by ID from the cars table. This is a cars table and these are our columns. We can specify order by to order data, limit to limit data, and offset to skip a specific number of rows. Aside from limit and offset, what we can also do is write queries like this. If we specify where year is like 200 and then use a percentage sign, our database will understand that as search for everything from the cars table where the year is 200 and then anything afterwards. Percentage means basically find anything. So we see that we have cars from 2000 to 2009 basically. The same works the other way around too. If we do just the percentage sign, we see that again we return everything. The database returns everything, and that's because we say select everything from our cars table where the car year is anything. So this is what the database does. It returns cars with any year, basically all years, and that's all rows. Percentages and underscores are called wildcard characters. So if we say that we search for a year like, then wrap this in double quotes, and then we say 200 and then underscore, our database understands that as 200 and one character afterwards. One character, any character afterwards. If we say 200 and a percentage sign like in the beginning, our database understands this as 200 and any amount of characters afterwards. The same works with the beginning as well. So we can either specify this in the beginning, in the end, or both in the end and the beginning. So if we come back and then issue a query like select all from cars where the car make is Mazda and the car model is something like C that has one character, what we get is nothing because there's no specific car model that contains two characters. We have CX and then 7, but no specific car model that has two characters that starts with C. So this is why we get nothing. But if we get a percentage sign here, we can see that the CX9, CX7 and other models are also included. And that's because we now tell our database that we want everything from the cars table made by Mazda with the car model that starts with C. So to recap, select tells our database to search for something. We use select queries to tell our database to search for specific data. If we say select star, we say select everything from, then we specify a table name, and then we specify a specific clause. So where something is equal to something. So if we say select from cars where year is 2005, our database will return all cars made in 2005. And we can also specify multiple columns with and or. And means that this must match and this must match. Or means that either this might match, either this might match. We can also have the between clause, and the between clause is used for numeric columns, for numeric data. If we say between 2000 and 2007, our database will return all cars made between 2000 and 2007. We may also specify that with less than or more than signs. As I said before, we can make it look identical. We can also order information within the select clause. So if we say select all from cars where year is a specific year, and then order by a specific column, we can make our database order data in a descending or an ascending manner. By default, the manner is ascending, as you can see here, from 1, 2, 3, 4, 5, and so on and so forth. We can use the limit clause to limit the rows that are returned. That may be useful for pagination or other use cases. And we can use, together with the limit clause, we can use the offset clause to skip a specific number of rows. Then we have the like clause, where we can use the percentage sign and the underscore sign. The percentage sign means everything. So this means the P letter and everything afterwards, and the underscore marks one letter. So P then one letter, and then Pontiac. This will return Pontiac. I hope you have enjoyed this video. Make sure to subscribe if you did, and until next time.